Hello folks, welcome to your online chemistry tutor, Chemically Yours. In this channel, we will be covering all the concepts of organic chemistry and we will be starting with the core concept, that is inductive effect. We hope you like it.
Okay, now we will be talking about the inductive effect. In chemistry, inductive effects are very important effects. So, first of all, we will talk about its definition. So, according to chemistry, the definition of inductive effect is permanent polarization caused due to displacement of electrons that to sigma. Only sigma, this is a very important part, only sigma electron causes inductive effect. No pi bond or no pi electron causes inductive effect along carbon chain. So there are many useful points about the inductive effects, and that you should cram and you should learn all these important points. So the first point is, it is permanent effect. There are many groups which causes these effects. Inductive effects is shown by probably many groups, and whenever that group is attached to any carbon chain, then it will cause a permanent effect of inductive effect will be a permanent effect. Second, it involves partial shift of electrons. This is not a resonance, okay? Resonance causes a permanent shift of or complete shift of electron. In here there will be a partial shift of electron, and because of it partial charges will generate. We will be talking in detail about these things. And third is, it is inversely dependent on distance. This effect is inversely dependent on distance. This effect increases as the distance decreases, and when the distance increases, this effect decreases. This is a very important and one of the most important point about inductive effect, which many of the people don't know, is that it can be neglected up to 3 carbons. It can be neglected up to third carbon. Till 3 carbon, like this, if there is a group which causes an inductive effect, and there will be effect on this carbon, there will be an effect on this carbon, there will be effect on this carbon, but the effect on these carbons and the later carbons will be very much negligible. It is approximately 0. So we will first, for the sake of simplicity, we will not consider the inductive effect being acted after these 3 carbons. However, they act, but we will not consider, just for the sake of simplicity. And fifth, when the scientists discovered these kinds of effects, they need to make a scale. And when they were making or creating a scale, then every scale should have a 0. And the scale in which we measure compounds and groups showing inductive effects, and we measure their polarizations, so that scale has a 0, which is called as hydrogen. Hydrogen is taken as 0 in scale. That is, inductive effect or inductive effect is measured relative to hydrogen. So these are 5 very most important points as inductive effects is considered. And then I will be discussing you the kinds of inductive effect groups and the groups which shows inductive effects. There are basically 2 types of groups which shows inductive effect. First of all, there are groups which shows plus I effect, and there are groups which shows negative inductive effects, and we will be differentiating between both of them. The plus I are also called as electron donating group. Donating group. In the later videos, I will be telling, or I will be abbreviate it as EDG, and the negative effect groups are considered to be as electron withdrawing groups. Electron withdrawing groups. And we will be discussing, or we will be abbreviating them as EWG groups. If you consider a carbon chain, and let us say that they have a EDG, and believe me just that Me3 is a EDG group. Later on I will be telling you that how EDG, how Me3 methane is an EDG, but just for the sake of simplicity or for the understanding, just believe me that it is a electron donating group. So what it will do, it will donate electron in this way. It will donate electron to the first carbon. Then after the carbon's vacancy, and for the sake of simplicity, I will be telling you the hunger. These carbons are very much hunger, and food for them is electron. So let us consider that they are the hungry children, and this is a mom. She is feeding food to all her children, and they are sitting in a line. So first she fed to her first child. When his hunger or his or her hunger is over, then the rest of the electrons will be given to the next one, or the next of the food will be transferred to the next one. And of course it has this carbon, or this child has consumed some amount of food, so the passed on food will be lesser than what given by the mom. After the hunger of this carbon is satisfied, then the rest of the food will be passed to this. And in the later stages, as I have told, that inductive effects are approximately negligible when we move further. So that inductive effect can be negligible as after third carbon. As I have already told, that inductive effects are inversely proportional to the distance. Now when this group or this compound is donating electrons, so a delta positive charge would have been developed on it. Do you agree with me? And a delta negative charge would have generated on this carbon. Okay, delta 2 negative has also generated on this, and then delta 3 negative, and delta 4 negative, and delta 5 negative, and there will be a negative charge will be generated on the carbon chain. Now let us consider an example again of 5 carbon with a group, electron withdrawing group, that is fluorine. Fluorine is also electron withdrawing group. Okay, so what it do, it withdraws. This is a vicious mom. She takes food from all of her child. So first of all, she take whatever the food the first child have, and when this child cannot satisfy cannot fulfill the needs of his mother, then he will borrow it from the next one, and the next one also borrow it from the previous one, and again they will be borrowing all the electrons from the carbon chain. And this effects also is negligible after third carbon. Whatever whatever will be the effects is shown, is they are shown in the first carbons only, first 3 carbons only, and then the effect will be negligible. So of course, if it is taking electrons, so a delta negative charge would have been developed on this, and a delta 1 positive charge would have been developed on this, delta 2 on this, delta 3 positive on this, and this goes as the carbon chain terminates, till the carbon chain terminates. So the second difference which comes between both of them is delta plus is developed on functional group, and delta minus is developed on carbon chain. Whereas in this one, delta negative is developed on functional group, whereas delta positive is developed on carbon chain. Now it is obvious that delta 1 negative, the modulus, okay, we are talking about the modulus. So delta 1 negative plus delta 2 negative plus delta 3 negative and sum of all the deltas, and their modulus will be equal to the delta plus, because as you can see that electrons have nothing go, and the electrons went nowhere, they are in the compound only, so the net neutrality of the compound is maintained. And similarly on this side also, delta 1 plus delta 2 plus delta 3 plus and sum of all the delta pluses will be equal to the delta minus, just to maintain the neutrality of the compound. Now let us talk about the examples of the groups which shows the effects of EWG or EDG. So the first is tritium, deuterium and hydrogen, and you must be very eager about that how we would place them on a scale, that whose effect is better than whom. So I will be telling you that the tritium has a better electron donating group than deuterium and then hydrogen. This is all because the tritium size is very big. The electrons last on the last shell. Okay, the tritium size is big. The electrons is on the outermost shell as compared to the deuterium or as compared to the helium. So the distance between electron and nucleus is very less in hydrogen, and it is somewhat mediate in deuterium and very large in tritium. So because of the less electron and nucleus interactions, tritium can easily give away its electron as compared to deuterium and as compared to hydrogen. With the same logic, I can also say that SiH3 is better than CH3Me, and this is also better than CH2 and also double CH, means all the carbon, that is methane, doubly bonded carbon, not doubly bonded, sorry, first degree carbon, second degree carbon and third degree carbons. And it is pretty obvious that CT3 has a better effects on than as compared to CD3 and also as compared to CH3, because on carbon there are 3 tritium which donates it electrons as compared to D and as compared to H, means this effect or this scale can be predicted through first one only. Now they are the first set of examples. The next set of examples is CH2 minus, NH minus, O minus, C double bonded O minus, and CMe3, CHMe2, CH2Me and Me, only Me. Okay. The CH2 minus is a better donor as compared to nitrogen, oxygen, and the series goes on like this. Okay, they are in series. This last like this one. So they are in series. So now I will be telling you the comparison, how to compare their inductive effects in this field. Let us say that C is an electropositive compound, okay, don't like electrons so much, and it has a negative charge on it, so all it wants to do is to donate it electrons. Okay, it eagerly or crazily wants to donate all these electrons to the carbon chain and want to remain neutral. But as you know that electron withdrawing groups are the shift of partials, not the not permanent, or fully electron is not transferred as in resonance, but it can, whatever it can do, it is very crazy to donate its electron, because carbon is not an so much electron loving compound. And as compared to the nitrogen is somewhat electron negative compound. Okay, it loves near electron, however its valency is being satisfied, so it is his prime duty that he should not take this charge and give away to the carbon chain. But however, because of his some love for the electron, it will not donate as much as electron as compared to the carbon. Carbon hates them, carbon will give them at any cost, but nitrogen, it loves at some cost. Now as compared to the oxygen is like a Romeo. Oxygen is Romeo and electrons are Juliet. He loves electrons. Oxygen is a very highly electronegative compound, and it do not want to donate all his compound, but just for the sake of neutrality of the compound and the stability of the compound, it has to donate, and it is not considered to be a very good It does not consider to be very good EDG group as compared to nitrogen and carbon. Now, how we would be comparing these two? Now, as if you are a rookie or amateur and you don't know chemistry, then it would be very tough for you to understand this. But if you have some knowledge about it, then I can tell you that this negative charge is on a resonance like this. Okay, it shows resonance. There is a resonance creature like this. Resonance structures are being made like this. So this electron resonates on this oxygen, and the next structure which is created is O minus doubly bonded O. And why this is considered to be lesser than O minus, and this lies in this reason lies in resonance. So look what happens. Although this group wants to donate its electron, okay, just for the sake of neutrality and stability of the compound, but the stability of compound is increased due to the resonance. As you all know, that stability increases as resonance increases. And resonance also, this resonance between similar atoms are even considered very good as compared to the resonance between non-similar atoms. So this is a resonance between similar. The electrons of oxygen are shared with the electrons on oxygen. I mean, they are a part of a same family and they are sharing their electron on their own. So it is very good. This is a father and this is a mother, and all they are doing is playing with their children. But the childrens are somehow more indulged with their parental activities, and they will not go further in the carbon chain as compared to what in O minus. O minus has no parental activity. This carbon is purely dependent on this oxygen only, it do not resonates anywhere else. So that's why it is more eager or crazy to donate its electron as compared to this, because in these two compounds electrons are somewhat shared, and because of the sharing of electrons there are very less electrons which are available for the carbon chain. So the reason lies in resonance. And if no problem, if you do not know what resonance is, then we will be covering it in the next videos, and then it will be very much clear to you. So the reason lies in resonance. Now, as compared to CME3 and these compounds are neutral compounds. Okay, they already have a bit stability. They are not like these compounds which require stability while donating their electrons because they have charge on them. They do not require stability. So already these types of compounds are considered showing less EDG effects as because they are already neutral and they do not have charge. So as I have told earlier that methane is an electron donating group. So this carbon has 3 methane on it. So obviously it will be better than the carbon having 2 methane. And it is also pretty obvious that it is also better than a compound having only 1 methane group. And again, it is very pretty obvious that this compound is better than a kind of a compound which has only 1 methane group. So I think I have already cleared the things in EDG. And I think that I have made yourself satisfied with the kinds of comparison between all the compounds. Now let us talk about the examples in electron withdrawing group. Okay, tell me, carbon hates negative charges on them. Okay, carbon hates negative charge on it. Likewise, nitrogen also hates positive charge on it, because nitrogen is an electronegative compound. A compound who loves electron, how can it would probably bear a positive charge on it? That is a lackness of electron in it. So it loves negative electrons. And if a nitrogen have a positive charge on it, then obviously it wants more electrons from carbon chain, because it hates positive charge. And as soon as it hates positive charge, or as much as it hates positive charge, he needs or he requires lots of amounts of electron from the carbon chain. And that's why N plus is the best electron withdrawing groups in the entire world, the N plus compounds. Okay, So first we will be talking about NF3 is far more better than NMe3. This is also better than NH3. This is better than NH plus, I'm very sorry, and this is better than NO2 plus. Then this series continues to be better than C triply bonded N, that is cyanide groups, then aldehyde groups, then ketones, they are ketones, then this groups further increase, and then doubly bonded carbons, and then triply bonded carbons. Now let us compare all these compounds with the satisfactory answers or explanations. So as I have told you earlier that N, nitrogen, hates positive charge, and positive charge on it is disastrous. So all it wants to do is it wants to take the electrons from the carbon chain. So how this is better than this, and I will be telling you. Now let us look at this. N plus, it is connected to a carbon chain here and has 3 fluorine as compared to the N plus who has 3 methanes. Now fluorine is an electron withdrawing group, as I have told here only that fluorine is an electron withdrawing group. So already nitrogen do not have any electron. Okay, there is a lackness of electrons in it, and furthermore fluorine is also taking electrons from it. See what kind of a disastrous situation it is, that already this compound or this atom hates the lackness of electron, and it is attached to the kind of a groups who loves electrons. So they are also taking electrons from it. Already he has lackness of electrons, so all it will be doing is taking a lots of electrons from the carbon chain. Now in case of a methane is an electron donating group. It donates electron. So it is donating electron to nitrogen. Electrons are donated to nitrogen. So a little bit of hunger of electrons in nitrogen is being satisfied with these methane groups. So it will be taking lesser food from the carbon chain. The food taken from the carbon chain will be lesser. That's why this compound has a better electron withdrawing effect as compared to this one. And obviously, as I have told that hydrogen is a relative, its scale is 0, so obviously this have been rated very less. Now the comparison between this and this lies in the answers of coordinate bond. As you all know that NO2 has a coordinate bond on it, and oxygen and nitrogen are sharing a kind of an electron. So whatever the electron it gets is shared. So this is even more worse electron withdrawing group as compared to these three. As we are going next in our series, there are cyanide, CHO and CORs. Obviously the electron withdrawing capacity of these compounds are even lesser than these one, because they have a positive charge on it and they are neutrals. So now cyanide is even better than CHO, because obviously you can understand that nitrogen obviously has 3 bonds. 3 bonds have more electron negativity. sp carbon, this is an xp carbon. xp carbon has more electron negativity, and obviously nitrogen is also an electronegative compound. This is also electronegative compound, this is also electronegative compound. So they both are taking electrons in a very satisfactory manners with the carbon chain. Now why they are not as much as good than CHO? It is because the carbon in this is actually, the structure is like this one. So the carbon is a sp2 carbon, and sp2 carbon has a less electronegativity or less affinity towards electrons, so it will be taking less electrons from the carbon chain. And also as compared to the ketone groups, because in the ketone groups the structures are like this. So obviously whatever the hunger of electron is present in the carbon is slightly being satisfied by the R group. So obviously it will be taking less food from the remaining carbon chain. And this you have to learn that double bonded carbons and triple bonded carbons are lies in the least in electron withdrawing groups, and double bonded is better than triple bond. Hello folks, thank you for watching this video. My name is Ishan and my cameraman is Abhinav. We hope that this video has helped you a lot in understanding this concept. Please subscribe it if you like it. We will soon be uploading many more videos.